Okay, this video is on the graphs of sine functions, and we are going to concentrate on amplitude, vertical shift, and reflection in this particular video. So there's a few vocabulary words I just want you to be aware of. The first is domain and range. Those are things that you've been looking at for all the functions we've covered up to this point. The domain for the sine and cosine waves that we are going to be looking at will be all real numbers, because these waves will continue left and right, but it is the x value of your graph. The range is going to be bounded, and it's going to be based on what your amplitude is and your shift change, your vertical shift. So the range will have boundaries. There'll be a high and there'll be a low, so we will have an interval to show what the range is. A period is one length of a wave. Most of our waves will be 2 pi unless we change the period. So 2 pi would be one rotation of a unit circle, and our period would fit the wave right there in that one unit circle. So we're going to start out with 2 pi on our waves, and then we'll change the period. The amplitude is the height of the wave, and we will talk about where the midline is and what the height of the wave is from the midline. Interval is the set of points within a certain area. We are going to use interval notation or intervals on our graphs to graph the critical points of a sine and a cosine wave, and you'll see what those are when we graph. Phase shift is another way of saying horizontal translation. In other words, that's where you move left and right. So how far did you go to the left or right? And then the vertical shift, of course, is how far did you move up or down. So let's start with the sine wave, and some things that you've already learned about a sine wave is that the sine wave begins here at 0, 0. The wave moves up, and it comes back to that same position. So one complete wave is what we're going to be drawing. Okay? Now typically it starts at 0 and it ends at 2 pi, because that is one rotation of a unit circle. Notice here that our amplitude from this midline to the height and midline to the low point is 1 unit. Now, if we don't change the amplitude is 1 every time. Okay? So, a couple of things we know. A period is 2 pi, and the amplitude is typically 1. A sine wave starts at 0, 0, moves up, and comes right back to the same position. Okay? So, let's look at a few sine waves. All right, we are going to be finding a period. Our interval, or our period right now, is 2 pi. And we go to graph this, we are going to use intervals in order to draw our critical points. So we're going to take our period, and at first it's going to be 2 pi, and we're going to divide it into 4 parts. And that reduces to give us an interval of pi over 2. So each mark is going to be 1/2 pi apart from each other. When we graph, I'll show you what that means. Now the amplitude is going to be very easy to see. You're going to be given an equation. The amplitude will be in a particular place. Alright, so here's a typical sine wave. We end at 2 pi. And we have an amplitude of 1. So here's our equation. You will need to pause the video and write this equation down, and write all of the components down, because you need to know where each of these numbers are, their position, and what they do to the graph. Okay? So this number here, whatever it is, will dictate how far we move up and down. So this is your vertical shift. Okay? Now your equation could look like this, or it could look like this. Now that plus 2 could be in the front or in the back, but notice it is apart from everything else in the equation. All right, so that's your vertical shift. This sign being changed to a negative makes it mean we're going to have a reflection. Okay, so that means we flip the graph over. Wherever it's at, we just flip it. All right, and we'll do a couple of those. And then the term right directly in front of the function, this is our function, it's the amplitude. Now, most of the time there's nothing there because it's an amplitude of 1. But if we have to change our amplitude, we'll put that number there. Then the period change is right directly in front of the theta. Now, sometimes they'll use the theta symbol. Sometimes they'll put an X there. It's whatever is representing the angle, okay? This C value is going to affect your period. It is the change in your period. So we're going to take our period, which is 2 pi, and we're going to divide it by that C value, okay, to find our new period. We won't deal with period change and horizontal shift today, but we will get to those, okay? So let's look at an example, okay? So here is y equals 2 pi, or 2 sine theta, all right? Our period is 2 pi for this graph. We're not changing the period today. Our interval, we're going to take the period and we're going to divide it into 4 parts. So our interval is pi over 2. All right, remember our graph for sine starts at 0. And right now we have an amplitude of 1, and then we're going to change our amplitude because of what's in our equation. But let's just do the original graph. All right, pi over 2, another pi over 2 gives us pi, another pi over 2, 3 pi over 2, and then 4 pi over 2, which gives us 2 pi. Okay, so my wave initially fits within this margin here, just like that. That's my wave. Well, this has an amplitude change to 2. So what's going to happen is we're going to stretch our graph vertically. And our new graph is going to go higher and lower than the original graph. Okay? So I still started at 1. I went up to 2 because my amplitude needs to be 2. Still at this 0. I went down 2 because my amplitude needs to be 2. And I came back to the 0. Okay? So my midline right here did not move. All I did was stretch it vertically. So we didn't shift anywhere. And the main things you're going to need to be able to name are our x-intercepts. So we'll just put where did it intercept x. It intercepted at 0, at pi, and 2 pi. Okay? Our maximum value is at positive 2. And our minimum value is at negative 2. This dictates our range. Our range is from negative 2 to 2. Our amplitude and shifting determines that. Our domain for all of these graphs are going to be all real numbers. Okay? All right, so let's look at something else. This time we've got a different amplitude. Okay? This amplitude is a half. We still have the same period with the same intervals, but this time we have an amplitude of a half. Okay, so if it's typically at 1, now my graph's going to shrink. Okay, so again, I'm going to put my marks. You need to make sure you mark your paper every time with the correct marks. And that will change as we change our period and shift. Okay, now typically we are at 1, right? This is our parent function. This is how it normally is. Well, since I have an amplitude now of a half, I'm cutting that width of my graph in half. And now I just have this skinnier graph. Okay, it's flattened a little bit more. There were no translations. Our maximum is at 1/2, and our minimum is at -1/2. So again, that dictates our range. That's our max and min represent our range. Domain is all real numbers. And our zeros did not change. We cross x 0, pi, and 2 pi. Okay? Now, let's do some shifting. Let's do some vertical shifts. All right? So we are still going to name our period. We're still going to determine the intervals. That's our period divided by 4, so pi over 2. So our tick marks did not change. Pi over 2, pi, 3 pi over 2, and 2 pi. Okay? And of course we do have a mark at 0. Our amplitude, look right here in front of sine. There is no number there. So our amplitude is understood 1. Okay, so I'm going to go ahead and graph the original graph of our function. Okay? This is our parent function. Now, we did have a translation. This 3 is a positive 3, so it made us go up 3. That means every point is going to go up 3. All right, so this point goes up 3. This point, up 3. Up 3. Okay, and there's our new graph. Now they are shaped exactly the same, have the same amplitude. Here's my midline. I do have an amplitude of 1. Okay, so our amplitude is the same. It fit within the same period of time. All right, this time our maximum is up here at 4. And our minimum this time is at 2. So that gives me a range of 2 to 4. Okay, my graph didn't go anywhere but between 2 and 4 on the y. Of course, all real numbers for domain. And did we cross x? There are no x-intercepts. Okay, so I want to do one last graph before my time runs out, and we're going to do one with several different things going on. Remember, we have a period of 2 pi, and when we divide that by 4, we get pi over 2 as our intervals. So we're going to mark our intervals, pi over 2. All right, our amplitude is directly in front of the function, so we have an amplitude of 2. We also have a negative in front of that, so it is a reflection. And we have a -2 in front, so that's down 2. That's our vertical shift. Okay, so I'm going to do the parent function with our amplitude of 2. Okay, and then I'm just going to put a couple more marks on here. All right, amplitude of 2. We're just going to kind of sketch that real quick. All right, took care of the amplitude. Now I'm going to move down 2. I like to do the movement before I reflect. So everything moves down 2. Every point moves down 2. Notice it is the same distance apart if my little graphing was a little bit smoother. Okay, and then we have to reflect. So that's usually the last thing I like to do. So the high number or low point comes the high, and the high point becomes the low. Okay, the midline does not change. So our graph, all that happened was that we took this purple graph and we flipped it over, and that's a reflection. So that now gives me a maximum of 0, a minimum of -4. So that's my range, -4 to 0. My domain is all real numbers. And I only had one x-intercept at 3 pi over 2. Okay, so we did vertical shifting, that's in front. We did reflection if we have a negative in front of the function. And then we did an amplitude change if there's a number in front of the function.